Hi, and welcome to our next level 3 integration video. We're now going to move on to integrating functions of 1 divided by x. In mathematics, we write lnx, which is called the logarithmic function, and it's a log function that uses the base number e. We just looked at e in the last video, so we're going to write lnx, which is equivalent to the log in base e of the function x. Now, remember in the differentiation part of this course, y equals natural log of x differentiates into 1 divided by x. If we have y equal to the natural log of a function u, then y dash, the derivative, becomes 1 over the function u, and then we must times by the function u dash, which is the derivative of u. Now, if that's the case, then we're going to go backwards and we're going to integrate the function 1 over x, and that's going to integrate back to the natural log of x plus our constant c. Now, we're using these straight brackets now, and the reason we're doing that, these are called absolute value brackets, is because we cannot take the natural log of a negative number. So what these absolute value brackets do is they take anything that's negative and automatically turn it into a positive. So if I try and take the natural log of the number -2, it's the same as just taking the natural log of the number 2. All right, let's get into some examples. Example 1, let's integrate 3 over x with respect to x. Well, we're going to break it up and say this is equivalent to 3 times 1 over x with respect to x, and therefore we're going to leave the 3 alone, and the 1 over x integrates back to the natural log of x using those absolute value brackets. So our final answer is 3 times the natural log of x plus c. If we tried to do it the old way with polynomials, we'd go 3 over x, we could bring the x up to x to the -1. We could then add 1 to the power and divide by the new power of -1 plus 1. And we had a problem. We showed you in an earlier video that we're trying to divide by 0. And this just doesn't work. So this is the way around getting around that problem. All right, example 2. Let's integrate 2 over 5x with respect to x. Well, again, we're going to break it up into 2/5 times 1 over x, because 2 times 1 is 2 and 5 times x is 5x. Now we can leave the 2/5 alone and we can integrate 1 over x to get the natural log of x. And that gives our final answer, which is 2/5 times the natural log of x plus c. All right, what about example 3? Let's integrate x cubed minus 4 all divided by x with respect to x. Well, here we go. We've got one thing on the bottom, so we're going to break it up into different fractions. We're going to break it up into x cubed over x and minus 4 over x. Now, the x cubed over x will simplify to x squared, because cancel one of the x's on the top and bottom. And the minus 4 over x, we're going to break up into 4 times 1 over x. So now we're ready to integrate. So the x squared will add 1 to the power to get x cubed and divide by the power of 3. And the minus 4 times 1 over x, well, the 1 over x integrates to natural log of x. So we're going to end up with 4 natural log x. And our final answer is x cubed over 3 minus 4 natural log of x plus c. Right, our final example is the integrate 1 over 2x plus 1 dx, and we're going to just treat this bottom function as u, so we're going to write it as the natural log of u, so the natural log of 2x plus 1, put it in the absolute value brackets, but we're going to divide it all by 2 before we go plus c. Now, why have we divided 2? Because normally we multiply by 2 when we differentiate, so that's the opposite process. We must divide by the derivative of 2x plus 1. All right, thanks for watching.